Day 422 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1498, number of subsequences that satisfy the given sum condition. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question said. You are given an array of integers nums and an integer target. Return the number of non-empty subsequence of nums such that the sum of the minimum and maximum element on it is less or equal to target. Since the answer may be too large, return it in a modulo 10 to the 9th power plus 7. All right, y'all, so that sounds pretty simple, but let's go ahead and take a look at these examples anyway, just to make sure that we're doing this problem correctly. So in example 1, we have the input nums equals an array of integers 3, 5, 6, and 7, target equals 9, the output is 4. Explanation, there are 4 subsequences that satisfy the condition. 3, the min value plus the max value is less than or equal to 3, because 3 plus 3 is less than or equal to 9. The subsequence 3 and 5 is 3 plus 5, which is 8, which is less than or equal to 9. The subsequence 3, 5, and 6 is 3 plus 6, which is less than or equal to 9. And 3 and 6, 3 plus 6 is also less than or equal to 9, which in this case, the last two are equal to 9. So let's go ahead and break this down one step further, just in case people still are a little bit confused. So we want to create subsequences in this array where when we take the minimum and maximum element, when we add them together, it's less than or equal to the target. So when we take this 3, so as you can see, we can create a subsequence with just 3, but when we do that, we still add 3 plus 3, right? So it's not like it's just 3 plus 0, it'd still be 3 plus 3, but 3 plus 3 still works because that equals 6, which is less than 9, which is less than our target 9. Boom. We could create this subsequence 3 and 5. When we add 3 plus 5 together, that's going to get us 8, which is less than or equal to 9 because our target, right? It's less than or equal to our target, which is 9. Then we could do this subsequence right here, 3, 5, and 6, because remember, we're just doing the minimum and maximum elements, so we don't have to include this 5 in our addition when we add the 3 plus the 6. That's why over here it's 3 plus 6, which is equal to our target, less than or equal to our target, which is 9. So that's how we got that, because we just took the minimum value plus the maximum value. We don't have to worry about all the values in between, which in this case would be 5. And then we can create another subsequence with just 3 and 6. And when we add 3 and 6 together, that gives us 9 as well. So with all that, we have, these are our 4 subsequences that we can create out of this array, where when we add the minimum element and the maximum element together, it'll be the sum of that will be less than or equal to the target. And in this case, there's 4 of those subsequences, so we don't have to return the subsequences themselves. We just have to return how many subsequences we can create, which we need to, will be important when we're writing our code. So just in case that didn't make sense, let's take a look at example 2, just so we can really bring this home and make it make sense even more. So in example 2, we have our input nums equals an array of integers 3, 3, 6, and 8. Target equals 10. The output is 6. Explanation says there are 6 subsequences that can satisfy the conditions. Nums have repeated numbers. So in this case, we could use this 3. Once again, that'd be 3 plus 3, which is less than 10, which would come from this 3 right here. Then we could use this 3 as its own subsequence, right? So that would be the same thing. 3 plus 3 would be 6, which is less than 10. Then we could do this subsequence right here with both the 3's. Once again, that'd be 3 plus 3, so that gives us 6, which is less than 10. Then we could do this 3 and this 6. When we add these two together, we get 9, which is less than 10. Then we could do this 3 and 6, which when we add these two together, which will give us 9, which is less than 10. And then finally, we could do this 3 and this 3 and this 6, because remember, we're just doing the minimum element and the maximum element. So we only have to use one of these 3's. And when we use one of these 3's, that will give us 3 plus 6, which will give us 9, which is less than or equal to 10. So in all, there are 6 different subsequences that we can create. So that's why our output is 6. Now let's take a look at example 3. Example 3, we're not going to go through all of the subsequences because there are so many, but let's take a look at it anyway. So in example 3, we have the input nums equals an array of integers 2, 3, 3, 4, 6, and 7. This time the target is 12. The output is 61. Explanation says there are 63 non-empty subsequences. 2 of them do not satisfy the condition, 6 and 7 and 7. So the number of valid subsequences is 63 minus 2, which gives us 61. So as you can see, this subsequence right here does not fit the condition, and this subsequence right here does not fit the condition. All other subsequences will fit the condition, but when we add 6 and 7, that'll give us 13, which is greater than our target 12. And then we do 7, that'll be 7 plus 7, which is 14, which is greater than our target 12 as well. So that will leave us with only 61 subsequences that fit the condition. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult, so let's get into it. First thing we're going to do is we're going to define the module constant to avoid integer overflow. So we can say let mod equal 1 underscore 000 underscore 0, underscore 000 underscore 007. Boom. And that's going to help us with this right here. Boom. Then we need to get the number of elements in the array, so we're going to say let n equal nums.count. Boom. Then we need to sort the array to enable 2-pointer technique and range calculations. So for that, we could say let sorted equal nums.sorted and put the parentheses at the end like that. Now we need to pre-compute powers of 2 module mod up to length n. So for that, we are going to say, so the power list of I is going to be equal to 2 to the ith power mod. I'll show you what I mean by mod in a minute. But so we're going to say, hold on, we're going to say var power list. We're going to set that equal to an array of integers. So square bracket int, and it's going to we're going to open up the parentheses. It's going to have repeating :1s, comma, count up to n. Then we're going to come underneath that. We're going to say for I in 1 dot less than n. We're going to open up the brackets. We're going to say pow list square bracket I equals int parentheses int 64, open up the parentheses, pow list square bracket I minus 1, come outside the square bracket and the first parentheses, we're going to say times 2, then come outside those parentheses, and this is what I mean, we're going to say mod int 64, open up the parentheses, and we're going to pass in mod from up here. Boom. Then we need to initialize our answer variable. So for that, we could just come right here, declare a variable called ans. We'll set that equal to 0, and that's going to store our output. Now we need 2 pointers left and start for our 2-pointer approach. So we're going to say var left, we're going to set that equal to 0. Say var right, we're going to set that equal to n minus 1. Boom. Now we need to iterate while the left pointer is less than or equal to the right pointer. So we're going to say while left is less than or equal to right, we're going to open up the brackets. And if the sum of the smallest and largest is too big, then we're going to decrease right. So we're going to say if sorted, open up square bracket, so sorted left plus sorted square bracket right is greater than target, we're going to open up the bracket and we're going to decrement right by saying right minus equals 1. Then we're going to say else if if valid, all subsets formed between left and right are valid. So we're going to say, come right here, we're going to say else, we're going to open up the bracket, and that means there are 2 to the right minus left power subsequences. So we're going to say ands equals ands, ands equals, open up the parentheses, ands plus pow list square bracket right minus left, come outside the parentheses, and we're going to say mod like that. Then we're going to increment left, so we're going to say left, come underneath that and say left plus equals 1. Then we need to return the total count of valid subsequences with the module mod. So we'll just come right here and we could say return ands, just like that, y'all. That should be all she wrote. Let's go ahead and give it a run. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Look at that, y'all. 27 milliseconds beats 75% of users. Not too bad. We could get those numbers up, but for now, we just want to be able to solve the problem that is presented to us, and I feel like this is a good solution for that, y'all. It's easy to understand, and we can all retain some information from this solution. So with that being said, y'all, let's make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.